Welcome to a new test and teardown video. This time it's a Lambda power supply model LG534. It should be able to give 0 to 120 volts, 1.7 amps. So yeah, that's quite a lot of watts, and it's linear. Output voltage is a multi-turn, and current is a normal pot meter. And then there's on-off. That's actually, yeah, almost all there is to it. Meter, you can select between volts and amps. It's only a 3-digit LED meter, so that's all there is. I mean, that will be a 1 volt per count, right? I got this real cheap at an auction like a half a year ago because this one was bought in USA, and they said that it was impossible to reconfigure this for Europe voltage, so that is why it was given up. I've been looking here at the seal. There is still a seal and it is still intact down here, so nobody was in here, and they said something about schematics, and I've been trying to Google around, and yeah, I can't find schematics online. And then I've been looking around in this instruction manual. It doesn't say service manual, but instruction manual, and it says a lot about what this one can do and what not, and all this kind of stuff. And so I was searching around in the manual here to see, oh, is it possible to reconfigure the voltages? And everywhere I see, it is USA voltages only. So that is a little bit of a bummer. But of course I can just test it the way that it is, right? But look what I found. Hidden in the manual. It's actually not that easy to find. It's only here because I know that I unfolded, see, this. Before I unfolded this, it was like sticky all the way together. So somebody's been poking around with this and they didn't see something else. Oh, that is not schematics. That can't be interesting. See? Also some mechanical drawings and I don't know what, boring stuff, right? But look what I find. Schematics. And not only my version, but all the different versions I got schematics of. And because they're using 2 different schematics of the many different models. See, I got the 534. And that means 120 volts, 1.7 amps, and blah, 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 blah. And then it says here, you know, different versions and whatnot in the schematics. And then we got 2 basic schematics. This one is all the low voltage versions. They're using this schematic. And the big difference that is here in the power regulator. See, there's an option here for lower voltage, more current. So regulators, they are now in parallel, more transistors in parallel, so you can handle more current. And of course we got different output voltages on this transformer. But look at the transformer. We got 2 primary windings, and they can be in parallel or they can be in series. And it even says here, so transformer in series on this and this options. So I think there is definitely a way to reconfigure the transformers, or my transformer obviously. So this is my high voltage version. See, this one got 2 sets of transistors in series for power distribution, I guess. So it's called a pre-regulator, the first one, and the other one is the one that is doing the real voltage and current and fine regulation. We got 2 ICs that's doing all the good things, this one and that one. I think I will scan this and put it on one of the normal public sites, and then I will put a reference or a link to this schematic in PDF file for your convenience. So if you want to look at this in a high resolution, good quality, please go to my description, download the PDF files. How about that? So I think I'll just try and power it up using USA voltage first and see if it's alive. So let's do the first power up together. It's gonna be more fun that way, right? So I turn this on and then I dial up the input voltage real slow and see if there's any shorts or anything. What have we got here? No. We don't have anything bad. 120 volts, and look, the thing is alive. Yeah, it may be alive, but bummer. Yeah, there's no output, so I mean somebody probably gave this 100 or 240 volts. Is that a smell? No, not a good idea. I turn it off. And then, oh no. Did you see that? This is not good. Okay, so there's something with the regulator stuff inside that is not doing its thing correctly. And no, this is not a nice way to power up or power down. The power up and power down sequence can definitely not be like that. So, whoop. This is not supposed to smell like this. And we are inside. The first I said was, wow. Oh, this is massive. It is really, really a beautiful build. Wouldn't you say that? Very big transformer, and this capacitor is probably that one, right? 200 volts. And we got separate diodes for everything. And definitely this is all the rectifier stuff. And then we got the pre-regulator and the output regulator. It's actually a little bit funny the way that it's made here. Look at that, on a big piece of aluminium and then wires coming up. There is a funny smell. I can't exactly tell you how this smells, but like something is warm, but it's turned off. So where the heck is the fire? I can't see anything. But I will definitely turn it on using a thermal camera in a minute. That is some... And it is heavy, like really, really heavy. Maybe all this is not aluminium. Because why is it so... The weight down here is almost the same as if I lift this. Why the heck is this just as heavy as the front? This is something I cannot explain exactly. And all this is not screwed together or anything like that. It's a very, very special construction. All the connections here on the back, they're exactly made. They are made correctly. All this minus and sense and power, this and that, that is done correctly. So, and the input here is also quite easy to take away if you want to do that, or change the wire. Oh, we got a little bit of output current versus ambient temperatures. So that's quite good. They specified all that. So I'm looking a little bit on the transformer, and This is of course mains entry, goes via this extra silicone high voltage isolation, and then it goes to the mains switch and then back, and it comes out here. So that will be the wires. See, goes via a fuse, really neatly located. But here comes the fun thing. So power entry is in parallel mode, right? So we've got two wires coming out. So this is C and B. So A and E and C and B, they're in parallel, right? And what I do not understand is, why isn't that explained here on the schematic, like A and B and C and D and thingy here, right? So, and what is D and F? It looks like there's a wire here. So I think I'll try and desolder those wires and try and input my 120 volts, and then I will see if there's 120 coming out of the other two wires. And then I kind of figured it out, right? But why is it made like this? That is so stupid, and it's not documented in any way, not even in the manual. Man. Well. Anyway, I found some date codes. So here is 91, and it's also 91 and 91 and all that. So I think this unit is from 91. A beautiful PCB. And it looks like it's single-sided, but with plated through holes. So why don't you put on copper tracks on the top as well? That is a little bit funny, right? We got some extra transistors there and all that. What is that little funny one? So that will be the volt amp meter. And there's a big beautiful chip right there. So I've just turned this on again. Let's look at this PCB right here. So this is how it looks like. And as you can, oh, that is real sweet with this lamp. Can you see that? 87 Celsius, and I just turned it on. And here's some other stuff. What exactly is going on here? $80 Celsius. So I think it's this transistor down there. Yeah. This is an IC. So I turned this off. So there's definitely something going on with that IC. Oy. That is bad. And what else is warm here? It's not that one, right? Okay, that is the... There was a capacitor down here. Or those diodes. But I think those are the diodes that's actually supplying the voltage to this board. And then this IC gets burning hot. So I'll try and see what that is on the schematic. It's probably not my lucky day. So here's the IC that gets very, very warm. It's just called IC101. And then there is a part number, an internal part number, right? This part number, I don't understand what that is. So now we need to figure out, what can that be? But then I looked in the manual again. Browse. Find. IC101 is an integrated circuit with this blah 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 number. Oh, should be 128 something. So that is not so good. Parts ordering, standard components and special components. Oh no, available through the Lambda office. Oh no. So I am absolutely stuck. That's what I think we need to do to reconfigure the input voltage. Remember those two extra wires that were sticking out here? The white one was mounted here to the yellow one and to A, and that one B was connected to the black one here. So that's actually the two windings in parallel, and those two wires here, that's actually the two center points. So if I connect these two together, it should be connected for a Europe voltage, and point D here is not connected to anything at all. So I think the trick is that I take those two wires and put to D, so at least I know where they are floating around, right? At least that is what I want to do, because I've been measuring resistance and everything here, and there's nothing to D. So I think that is safe to do. And yes, I was of course right. So now I got 220 something between these, and I got half of it on that point. And now I still got the problem, of course. And if somebody was doing this some 40 years ago, or whatever, when they got this, we wouldn't have this problem after all, right? So somebody's been connecting this cable into 230 volts, and it is of course wired to 115. Damn it. And that is of course why this IC is blown up, and I don't know what the heck that IC is. I can't read the text. It is it's because it has been so warm, so the text is kind of gone. So I am a little bit stuck here. So I am breaking down my tiny little success stories in tiny little bits. Yes, I'm super happy about the 230 volt modification, so that was super easy to do. I'm still a little bit angry about they didn't add the correct labels to the transformer inputs here. That is a little bit stupid. Could have been easy, right? So what I thought was an error, this red hot IC here, it was about 110 Celsius, and I mean that is way hotter than any normal op amp or amplifier chip or anything else that I have seen the last many years. So I was totally sure that it was that chip that was to blame, and it also got a very special part number. It turns out that this IC Lambda also use exactly the same part in many other power supplies, but here it's called LAS3700, and it is exactly the same part. And the LAS3700, you can actually, if you're really smart and intelligent, you can find the data sheet. It was very tough to do, and I used some of my friends to find it and get it, and now I know where it is. It is actually possible to find it, but I will put a link to that data sheet in the description of this video, so you too can look this up if you want to. I think with the data sheet of this IC, it's a little bit easier to understand what is going on in this schematic and to debug the rest of the features. So I actually know now by reading the data sheet that this part is supposed to run this warm. There is a built-in heater and a temperature regulator to heat it up this much, and that is to keep it nice and stable and accurate, because this is what is performing the voltage regulation. So that is why it needs to be this warm, because the reference is in here as well. So it is not to blame for the problem that I have, and now I need to look elsewhere for the problem. So now I've been looking a little bit on the PCB. So like, where is the fault? Where can it be? And then poking a little bit around. But what do I see? Look at that. There's a wire that's not connected. And I think it is supposed to be connected to that point right there. I've been using my best skills of detection here to figure this out, but I think, don't you think, wouldn't you agree? It got to be that, right? So I'll try and cut up a little bit of this wire here. Maybe I can make it a little bit longer, and then try and solder it here and see if it works. Can I be this lucky? I don't know. So this is going to be interesting. I did actually just cut away some of the little strings here that's holding all the wires, so now it's a little bit longer. And let's turn on the... I got 1 volt. And look at that. It is responding. Lucky. And meter is in amps. Okay, so the voltmeter is 20. Like that. Oh, look at that. One happy camper. It is working. That was so easy. The only thing that really fooled me, that was this thing with this burning hot IC. I really thought it was a defect IC, but that is normal. Let's play. See, this is a real nice multi-turn. And I mean, it's probably still warming up. Let's see if it can go to 120. This one should be specified for 120 and it's only 116. I am disappointed. Only 116. So what is the problem here? Is it my input that is a little bit too low? Let's crank it up to 229. No. I want more. Well, that's probably a pot meter that sets the maximum. Oh, it is coming slowly. How about we try to load this thing and see if it can give some amps? It really seems like it's working. So this is in amps and this is 1.23 amps. And I think it is almost what I got. I cranked down the voltage a little bit because 86, because I didn't want to make it too warm or anything. But it's actually the opposite that is happening. When you crank down voltage on a linear power supply, you know, it's your load you're gonna make colder. When you do this, you're gonna make it much warmer. So here's the funny thing. If I got like 60 volts and 1.2 amps of output, okay, so that is about 73 watts of output power. So what do you think is the input power? Is 230 watts. Hallelujah. So there's something here that will get warm in a minute. Now this is of course super funny. Maximum voltage 1.2 amps, it's the same. So full voltage, this is not full, far from full, but this is 146 watts output. And then the input is 230 watts. So what happens when I dial down the voltage all the way down to minimum? Okay, only 1 volt output and it's still 1.23 amps. 1.2 watts is my output, and what is the input? Still 230. The joy of linear power supplies. That is how it is. So to be able to understand all that loss, let's try and measure the voltage. 182. on that one. That is something, isn't it? So that is of course why it gets so warm. Of course there's also a lot of loss in the transformer. But that is how this thing works. Super linear. Not any, no, we don't even see those relays with tappings or anything fancy schmancy here. No. This is just a heater. It's really big and hefty. Could be fun to try and load this for a long time and see how warm it gets. I added a thin layer of my black varnish here so I can measure temperatures. What is it we're seeing here? Only 90 Celsius, but it's also so super much out of focus. Let me put on my macro and let's try again. And here we go. Oh, only 93, 94 today. See, we also got a little bit of other hot components here. But that is expected. It was actually supposed to be 110. I think it's because it's open here, I get a lot of air. But anyway, I think I don't want to talk a lot more about this power supply. I'm super happy it works. And thank you very much for watching. It was fun. See you tomorrow.